Hi, welcome back, everybody. We are next. I'll just give it one more second because people seem to be coming in. Okay. Our next speaker, we're really pleased to have Elliot Ash. Elliot is an assistant professor of law, economics, and data science at ETH Zurich Center for Law and Economics in Switzerland. And today he'll be talking about telling the tale, narratives, and emotional intensity in political text. So Elliot, over to you.
Thank you, Rochelle, and thank you everyone for having me. Thanks for joining this session. I have some slides that I'll share. So as Rochelle already mentioned, today I'll be talking about telling the tale, narratives and emotional intensity in political texts. And I'll be sharing a few examples of my research using computational social science tools and Python in particular for use in law, economics, and data science. So just to start off, I think we can think about today's session as telling the scientific tale with Python. And I'm happy to be around a lot of friends where I can preach to the choir that Python is the best language for scientific programming and Python is fun. My team used Python for computational social science, mainly for empirical analysis using text data. And today I'm going to show 3 examples of that. So first, I'm going to talk about measuring emotionality in text using word embeddings. Second, I'll talk about unsupervised text classification using transformers. And third, and finally, I'll talk about mining narratives with semantic parsing. We have already some beta and open source code for our tools, and I'll go ahead and copy this link into the chat because let's see if I can do that. Here we go. Feel free to check out the source code in at that link, and I'll show a few snippets in the slides, but if you want to see how it works, check it out. And we showed the GitHub repos where the code comes from. So first, I'll talk about emotion and reason in political language. This is joint work with Gloria Gennaro, who's a postdoc at ETH with me. And it's motivated in part by this quote by Drew Weston, where in politics, when reason and emotion collide, emotion invariably wins. This is a really great quote, and I think there's some intuition behind it. And what we want to do in this paper is show some empirical evidence, use this this insight or this idea to see what the data say. But the problem is that emotion is something that's in speech or in text. What we're going to be looking at the transcripts of the speeches in the congressional record, and there's not just like some metadata for measuring if somebody is doing some emotional expression, and so we have to design some tools to produce a scale for emotion. Our corpus is this really amazing resource in political science, political history, just in social science generally. The universe of floor speeches in the Congress. Of course, it's available today. Our version is from 1858 to 2014. So 150 years of speeches is a really amazing place to start. It's also almost 10 million speeches. So we're talking about big data. You can't just put this into Stata or to Excel and do anything with it. We need to use Python. And so throughout this talk, I'm going to put in red in brackets when we're using some Python tools. And I started doing this, and it was amazing how I had never reflected on how much we use it. It's really just amazing where this community of scientific programming in Python has gotten. We're really standing on the shoulders of giants here, the giants of open source code repositories, and really thrilled to reflect on that today. So first of all, we use NLTK, everybody's best friend, the natural language toolkit. We use WordNet to get at lists of nouns, adjectives, and verbs. We do some pre-processing. We use the snowball stemmer, and we do some vocabulary pre-processing. The second Python tool we use is Word2Vec from Jensen, which was used in the previous talk. This is a classic. We take advantage of this classic feature of Word2Vec that the directions in this space the word embedding space correspond to semantic dimensions in language. And so, the classic is, man to woman being parallel with king to queen, for example. We're going to do that to map out a dimension from emotions to rationality or reason. And you can see clearly how this dimension works from these word clouds. We're using the Python word cloud module, which is just the best, right? And we use NumPy for vector algebra. And so we start off with the word embeddings trained. We have a list of emotion and reason words, and we construct a vector or a location in the space for emotion as the average vector of the emotion words. And we have another vector for cognition or reason or rationality as this list of words. And you see this nice set of pretty intuitive words. So here are the positive emotion words. And so this is like positive sentiment. And these are like the negative sentiment emotion words, positive sentiment rationality words, and negative sentiment rationality words. And this is what you look at this and like, okay, wow, we're really capturing something intuitive in language. So now that we have this dimension of emotion and reason in language, we want to identify that dimension in speeches. So we want to scale the speeches by this. First, we take the average of the vectors of the speech. And we use, I loved that we have a SciPy piece of code in this presentation. We use SciPy's implementation of cosine distance to produce this measure of the relative similarity to the emotion dimension relative to the similarity to the cognition or the reason dimension. And after you have this relative scale, you can look at the example speeches along it. And these are just a few that of the highest and lowest rated speeches along that scale, limiting to the abortion topic. And I'll let you just glance at a few of these and guess which of these columns is more emotive and which of these columns is more cognitive or rational. And it's pretty clear. And we can compare the intuitive or the effectiveness of this scale more systematically using a human validation survey, where we scored a set of sentences as more or less emotional by humans, as well as our scale. And our automated scale using embeddings matches human judgment over 90% of the time. And especially usefully, it matches human judgment even in the historical case, where even going back to the 1850s, so we can have some confidence that we can measure emotional content intensity even back in the 1800s. So what do we do with this? This is our first graph, which we couldn't have made this without our new tool. And this is just plotting the emotional intensity measure for the House in green and the Senate in red over starting way back in 1858 up until 2014. And you can see that there's some spikes in there, like during the times of war, which is pretty cool. We use matplotlib. We also have some graphs using Seaborn, but you can really make some beautiful plots with these tools. And you can see this I think was the most striking piece that when we first just looked at this graph, is that starting in the late 1970s, around 1980, there's this big increase in the emotionality of congressional speeches, both in the House and the Senate. And we were thinking what was going on back then. And it turns out that's when C-SPAN, which is this cable TV network, started. And so right around this point, all of these speeches started being televised. And we do a lot of robustness checks to show this isn't due to other changes in emotionality in the rest of society, changes in partisanship, changes in sophistication. It really seems to be an emotional intensity dimension that's responding to the introduction of television. So next we use LDA. We use actually LDA mallet as was used in the first presentation. And so we take 128 topics and just we start off in panel A, just ranking the different topics by emotionality. And we have a set of topics about the national narrative, like the American dream, the American people, soldiers, and stuff like that. That's the most emotional one, which makes sense. Foreign policy and party politics and social issues and immigration are also emotive. But procedural topics are not very emotional, which this is really intuitive. Next, we compared emotionality by the parties. So these are the Republicans and these are the Democrats in terms of how emotional they are on the different topics. And one thing, I'm a public finance economist. I work on taxation issues, and I was really excited to see that Republicans are most emotional on fiscal policy. So on taxation issues, you can imagine, like especially starting in the 80s and 90s, really it started happening in the Reagan Revolution, where they started introducing these inequality enhancing policies, increasing inequality so much in the last 30, 40 years. And they're using all these emotional appeals to fend off redistributive policies. I think it really gives you an insight into how political rhetoric works in this system. Do I need to reshare?
Yeah, it looks like you, the slides folded on us.
Is that working now?
Yeah, that looks good.
Okay. So another thing we looked at is when Republicans or Democrats are in the minority or majority in government, how does that affect their level of emotionality? And we made this graph, and we were really excited about it too, that really, if you look at just these long epics where either the Democrats are in the majority or the Republicans are in the majority, the other party is using more emotionality. So you can see it really, really clearly here. And we know it's not driven by like procedure and things. When parties go into the minority, they start using more emotion. And this, I think, is kind of intuitive. Like, they're feeling they need to make these appeals to try to regain power. We also show that it works on Twitter. These are, we made this on a corpus of Republican and Democrat congressmen. So these are in red, like some Republican emotional hashtags. And these are some Republican, reason or rational hashtags. And in blue, you have like, March for Our Lives, Black History Month. These are the Democrat ones, right? And so it works on Twitter as well. In our source code, which you can pull from here, we have a tutorial or an example to produce the affect and cognitive scores in this corpus of tweets. So check that out. The second topic that I wanted to talk to you about is unsupervised text classification with transformers. And this comes from this question of what is this about? And it's the starting question in human machine reading of text documents. There's many previous methods. We don't need to talk about them. What we do is we combine some tools from transformer-based NLP and some computer vision tools, actually, from a recent computer vision paper to learn document topics without any labels. So it's related to topic models, but we'll show that in terms of identifying specific topics or specific classes that a document is about, our model will do that better. So this is motivated by it's kind of an obvious, it's not that surprising insight from this paper called SCAN, which stands for Semantic Clustering by Adopting Nearest Neighbors, that if you do some pre-trained encoding, so you get like a vector for the image or a vector for a document, the neighboring images or neighboring documents tend to be in the same class when you're looking at a annotated data set. So this is like the 20 news groups is this kind of standard text classification data set. The neighbors in the embedding space also tend to have the same topic. So we use that as motivation for training this unsupervised text classification system. The scan algorithm, this is the most technical part, which, unfortunately I have to go through a bit quick, but please check our paper and I can answer questions about it if there are any. First, we need some pre-trained representations. We use SBERT, so we get a 768 dimensional vector for each document. We assume that there's k topics, and in our experiments, we just take the true number of topics, but actually we have a method for learning the number of topics in a corpus without any labels. And then for each observation, we pick in closest images or document vectors as positive samples in our training process. The scan objective, I'll talk about it more in the next slide. And then we have self-labeling of confident documents. I'll show you some examples of that. The scan objective is implemented in PyTorch. So we have a data point and one of its neighbors. So it's like a positive sampling objective. We need to learn a function that transforms the input vectors into output vectors. For us, we actually just apply a classification layer onto the encodings. And what makes this work is you have these two combating objectives where we reward a higher dot product of the topic vectors. So basically, we want to reward two documents that are neighbors being in the same class. And this pushes neighbors toward being in the same topic. We also have, this is why the scan objective works. We reward higher entropy over the outcome shares. So it pushes, this works to push all of the embeddings into different classes, and it prevents collapse into a single topic. So we just train this until convergence, and we can evaluate it. And I think it's actually kind of amazing that we actually we look at these annotated data sets. So we have just 20 news groups, for example, a few thousand documents with their topics. If we run our docscan method on it, what comes out of the clusters? Is it the same topics as what humans had annotated? And so these are our main results, where we actually have 5 different text classification baseline data sets. Random baseline, this is just like the probability of the largest class. If you run TF-IDF with k-means clustering, you get a nice improvement over the random baseline. Another big improvement if you just apply k-means clustering to the pre-trained encodings. And it turns out that actually topic models are pretty bad at this task. So if you take a data set that has 10 topics, you train LDA on it with 10 topics, the top topic that LDA gets will not recover the true classes. However, DocsCan recovers the true topics quite well. So you can see that across all of the data sets, we get a big increase over the baseline approaches. And if you use one of our 2 variants, you're going to get pretty good performance at detecting the correct topic, and actually almost as good in some of the data sets as a supervised classifier that actually views the topics. So this is a new and very useful way to cluster documents and figure out what they're about. So in the notebook that we've linked here, we have some source code that you can actually run it and pick a lot of options. We actually have a cluster inertia method to figure out the number of topics. And in the Trump tweet topics, we see a lot of this works pretty nicely. This is obviously the fake news topic, China, the border, complaining about TV, the media, global warming, Obamacare, and then you can look at some examples too. So this is one of the topics is true, so true, 100% true. It really does grab these semantically related statements and puts them in the same topic. Okay, one final application that I wanted to talk to you guys about, and then I hope we can have Q&A. This is a joint paper. We don't have a paper yet, but we're about to. But I already posted the source code with Germaine Gauthier and Feline Bidmer. We're interested in narratives like this. Higher taxes will hurt the economy, health insurance saves lives, immigrants steal our jobs. And we want to identify and quantify narratives as an input to qualitative and quantitative analysis. The first ingredient that we use in this paper is semantic role labeling. So we actually use the Allen NLP semantic role labeling system. You can see the demo here at this link, but it takes sentences and extracts the agents, verbs, and patients. And so really you identify who does what to whom. This is really the atom, the unit of stories, of narratives. So a problem that we get once we identify all of the agents, verbs, and patients in the data set is that it's very high dimensional. And so we have like a lot of different phrases referring to different people, organizations, and events. The first way that we try to dimension reduce these items is named entity recognition to identify, President Bush, President Obama. But beyond that, there's many ways to say things like tax cut or tax decrease, tax decline. And we use embeddings and clustering similar to what I just told you to identify equivalent entities in the text. And so you can see even on this slide, there's just a lot of Python packages going into this. So here are some examples of entities. So, people, American, government, healthcare, there's just many ways these entities can be referred to. And our clustering approach identifies that pretty well. So some of the popular narratives that we see in the Congress include, people lose job, American lose job, citizen abide by the law. You can start to see these narratives in political discourse coming through in our narrative counting method. One thing that our approach captures pretty well is key historical events. So for example, in the run-up to the Iraq War in 2002, there was a lot of discussion about Saddam Hussein having weapons of mass destruction. And then once there was the invasion, one thing we found is that there was a substantial increase in religious language in the congressional record. So it seems like the use of God blessing the troops, God blessing America, seems to be a response to being in a time of war. We also used NLTK Vader to rank the sentences by their sentiment, positive or negative. And we were able to show that they capture emotional resonance. So, for example, the most negative narratives are about corrective actions to save families, terrorists, Iraq, things like this. The most positive narratives includes, establishing the Constitution, promoting the welfare, saying that kids should have health care. We can really see we get a new view of what the congressmen are talking about. As you would expect, these narratives also map ideological disagreements. So here are the Democrat type narratives. They're worried about the budget ending Medicare, America's losing their unemployment benefits, budget cuts. Whereas Republicans have very different priorities. They talk about government approved healthcare, American relying on oil, God bless men and women. They're worrying. They're criticizing global warming. You can see that partisanship comes through really well with these narrative tuples. Finally, and I'll point you guys to this. I'll show you guys this in a second. We use Network X and PyVis to make these really cool looking visualizations. Let me actually just show that really quick. This will only take one more minute. So you can see the link in I'll put the link in the chat, but we use Network X and PyVis to make these awesome apps, like web apps of like, some, you can see like family have healthcare, employee provides healthcare. And then in red, you have the Republican narratives. In blue, you have the Democrat narratives. And so you can see, a doctor takes medical care, doctor makes decision, doctor provides service. You get these really amazing, we didn't have to make this, right? Like the Python tools provided this for us. It's really, really great. So to conclude, We have a code base. I want to call it Yarn, as in yes, automatically reads narratives, but we haven't finalized on a title. If you like that title or you can think of a new one, let me know. But it works in Google Colab. It works in Mac and Linux. It doesn't work on Windows yet, but using Google Colab, and it should work for you. And to recap, we're telling a scientific tale with Python, and we used it to analyze emotions, to learn topics without labels, and to extract and analyze core narratives. So a shout out to my co-authors, Gloria, Dominic, Germain, and Feline. And as I already showed at the beginning, there's more info and links here. Thanks, everyone, and I'm happy to answer questions.
Great, thank you so much, Elliot. Like a true politician catering to the audience, the Python audience.
Yeah, a little
was very.
Okay,
so we only have a few minutes here, so I'm going to. I just realized that we can order questions by upvote, so I'm going to do it that way. So could you? Kevin wants to know why you used NLTK as opposed to another package.
This is for convenience. It depends on the task, but we will often compare it to NLTK or SciPy. And for some of the tasks we've used, NLTK is a bit faster, and SciPy was only slightly better. But that's for convenience. I think that for part of speech tagging, things like this, SciPy would be the place to start.
Great. And will you be putting the slides up so that we can access them later?
Oh, thank you. Yes, yeah, I will. I'll put them on my Twitter, or I'll put a link to them at that collab.
Yeah, that would be great. Julia wants to know, would you expect that the demographics of your raters would impact their labels? So do you have any way to infer demographics from your human labelers?
Interesting. Yes, actually, we looked at that. That's a good point. We checked this. In particular, this came up that we were wondering whether women and men might interpret emotional text differently. It turns out that men and women in the labelers, it didn't make a difference. Age made a little difference. So the older labelers, they were more. Our measure tended to agree with them more. Also, we have some information on demographic minorities, ethnic minorities. They actually tended to agree with our measure more. This is an important issue, but we did find some differences there.
Yeah, that's really interesting in and of itself. Excuse me. Okay, so sorry, I lost track. Okay, so Melvin has a question I was wondering about too, which is that how do you account for the historical effects on emotions, given that emotion is also a historic byproduct and are expressed differently over time? Certain periods are more emotional, perhaps leading people to use even more emotional words, probably in general. To add on to this question, different words have a different emotional connotation, I would imagine, in different historical contexts.
Yes, this is a tricky issue. We've thought about it. We have to make a little bit of some assumptions, but in our human annotations, we provided them, even though they're modern, I guess. So we have to make an assumption that people can look at two sentences in the past and say which one was more emotional than the other. We don't have to say that they can correctly scale something on 1 in 10, something like this. And we find that even in the 1860s, you give people two sentences and say which one is more emotional or not, and our scale will reproduce that ranking. So it could very well be that, like one of the classics ones is like the word awful, for example. It used to actually mean a good thing, but there's many examples like that, and so we have to in some way we have to we can never fully rule out that there's just differences and that our current annotators can't fix that, and it would just be too expensive, I think, to try to hire some historians or people who were experts at that time to check. But maybe that's something to think about.
Yeah, and I would imagine that you could perhaps extend this method just to see if there are more emotional periods in society, such as right now, for example.
Yeah. Right. So one thing that you might want to know is do people use explicitly emotional language versus implicitly? I think our method could get towards that, but it's not something we've explored yet.
All right, so does the analysis between Democrats and Republicans account for the switch in party platform that occurred in the 20th century? So if for our non-political science friends, the Democrat platform kind of radically changed during realignment in the 50s and 60s. And how does your method account for that?
It doesn't directly. So we didn't see like a significant shift in like kind of like the partisanship or emotionality at that point. So there were important changes for the Democrats then, but at least as measured by our emotionality measure, we didn't see a big shift. So I'm sure like many of the topics they were talking about were changing, but really the big shifts we saw were, let's say 10, 20 years later, when C-SPAN came about.
Yeah, well, that confirms my pre-existing belief that C-SPAN marked the end of our society. Thank you very much, Elliot. That was a really fascinating talk. I'm sorry that we went a couple minutes over, and we'll see you at the next one.
Thanks, everyone. Bye.